Hello, welcome back to my tutorial series. I thought I'm gonna take a slightly different approach to these tutorials. I'm going to try and aim what I'm doing at specific programming techniques. So I thought in this tutorial I could discuss kind of, so I could give you a demonstration of how to use a multi-dimensional array in a real scenario. So we have discussed this previously a little bit about how I'm saving the game board for my Connect 4 app in a 2D integer array. So what I thought I'd do is I would just discuss a little bit about how I then interact with that within my program. So in the last tutorial we discussed about how we derived the position of we derived the location where the user's counter was going to be placed. So the user picked the column, the program determined the row automatically, because obviously there's a risk that if you let people enter the row as well, people are going to be dishonest, people are going to just type in silly values. So as a result, take it out of their hands, don't let them enter a row, just simply say which column of the board you want to enter it in, and then the program is going to tell you, because the program knows which slot is correct. It can calculate it for itself which slot's correct. So you might as well go to the extra effort rather than trusting the user to be honest and placing entering the correct value for a row. So now that we have this move in this row, we can identify an element within the 2D array. This is the first time we've actually used the 2D array. So I'm trying to remember which way around it goes. I want to say that this will represent the 7. That is the column value. So that is basically the x coordinate, and this is the y coordinate. Whether or not it means that I have 6 arrays within my 2D array, each containing 7 elements, or if it's 7 arrays containing 6 elements, I don't know. I have a feeling that it is going to be, this is the number of elements and this is the number of arrays that I have, because that's how 2D arrays work. 2D arrays are any number of arrays within an array. It's an array of arrays. Like a 2D grid is, every row is a single array, it's multiple values, and then the grid part is having multiple sets of multiple values. So I'm gonna stick to my guns and say this is the element which I'm looking for, and this value determines which array that element is in. Is that the right way of working it out? Well, no, sorry. The better way of putting it would be which array that element is referring to, I guess. It's kind of back to front. A better way of describing it is this is the array that I want to access, and this is the element within that array. That's a much cleaner way of doing it. So anyway, now that we have that, we have one specific value within the entire 2D array which we're going to edit. And all we're going to do is we're going to place this counter variable into that array. So initially, the way this program's set up is all the values in the board are set to 0 by default, since at the start of a Connect 4 game, all the slots are empty. So 0 represents empty. The counter variable differs between 1 and 2, as you can see down here. So player 2, the count as 2, player 1, the count as 1. So and that's no different to coloured counters in a board. It's the exact same way of it's the exact same methodology. So what this statement's doing is it's picking out a specific element within the entire 2D array, and it's gonna assign it the value counter, i.e. it's gonna place the player, whoever's turn it is going to place one of their counters into that slot. The next thing that's going to happen is we're going to set a game board. So this is a little bit, it's a slight detail. It's not really about 2D arrays. This is just about global variables. So what I'm doing is I'm passing this board as a parameter to match the parameter of this, the required parameter of this method. It requires a 2D array to be passed to it. And what this method's going to do is it's going to receive the game board after I've placed a counter, and it's going to essentially save that change to the global variable. I.e., it's going to make the 2D array, this board here within my constructor, equal the game board for the entire project, and that is the global game board up here. You can see that. So that's how that's working. A little thing to point out: the this keyword refers to oh, this is difficult. It refers to the object in which the method resides, I want to say. So if you've ever done object-oriented programming, you know that you have sort of methods / functions and attributes. So in this instance, any global variables are, in this instance, game board is an attribute of the main class object. So that is this here. So I believe if I wrote main class, I think that, oh, okay, that wouldn't work. Why wouldn't that work? Why would that not work? Ah, yes, okay, I know why that wouldn't work. Okay, so my understanding is by default that the Java compiler will create an object of main class automatically. And that I can reference that using the this keyword. However, if I try to just call the class, it's going to get upset with me because I need to create an object of the class. So this basically bypasses that step. This keyword bypasses that step. But this here, when I type main class, the problem with that is that this is being initialized, like referenced in a what's called static context. What that means is static means that you can have static methods and you can have static variables, and what all they mean is that they mean that they can be accessed without creating an instance of the class. And that's kind of what I'm doing here. I haven't actually created a new instance of main class. I'm just referring to the class itself. And that means that I'm referring to it in a static context. Since game board, the global variable, is not static, there's no static here. If I make it static, if I can spell, if I make it static, this works. It goes weird italics, and this will now work, and that's absolutely fine. However, for my purposes, I don't want to do that. So I'm going to remove that, and you'll see the error returns. So I can do this. If I do that, and then I change that to main, yeah, that works. So what I've done is I've created an instance of the class, hence this is no longer a static context, and therefore this attribute can be called just fine. For simplicity though, Java presumably it sets up an object by default. I don't quite know how it works, but this keyword just bypasses all of that, and I can just put that in its place. And this is a standard way of setting up getters and setters. Getters and setters are a standard programming technique, and this keyword is typically how you would achieve this functionality. Yeah, just a little side note for you. I want to discuss one more thing. Yes, I thought I'll talk a little bit about the print board. So I think I might trim that down for simplicity. I'm gonna do that. Okay, so this print board method is just going to display the board to the user once it has been once their move has been saved to the game. It requires that the board that is going to be displayed. It takes that as a parameter. So you pass it the array which you want to display, and then all this board does is it simply loops through all the elements within the array and prints them out on the board. It prints out a line of them, each with a space in between, and then every time you reach the end of it, so every time you've completed a row of the board, it's going to print a new line, it's going to move on to the next line, and it's going to print another row of the board. You'll notice that this for loop at the top is inverted. So the bottom one is counting up from, it's going to go from 0 all the way to 6, since 7 is not less than 7, so it's going to fail at that point. It's going to go from 0 to 6. It's going to count. I say count up, it's actually going to count across. If you're thinking of it in terms of the grid, it's going to go from left to right since it's the x coordinate. In this instance, it's going to go from up to down. And the reason for that is because the top row needs to be displayed first. You know, if the y printed from 0 to 6, 0 to 5, no, 0 to 6, yeah. So it would print from value 0 to 5, it would fail at 6 because there's one less row. If it did that, what would happen is that the board would be basically upside down. So because of how the game works, if you think of the x and y axis, they meet at the corner, and the corner is 0, 0. Well, in order to replicate that, you need to invert your y, since a computer displays going down, but actually we would want it to display going up. So in order to do that, we have to invert our y so that our y counts down. It's kind of tricky, but it works. It works. Basically, if you wanted to display, I think is it a Cartesian coordinates? If you're wanting to display something with 0, 0 being in the bottom corner and y going up and x going to the right, you need to invert the y. And in doing so, you'll end up with the correct, it'll display correctly. Just a little thing on how this is counting, and I think I'm going to wrap this up. So what this statement is going to look at, this print statement, is going to look at the x value and the y value. So on first execution, it's going to print this value. It's going to print the value of 0, 0. It's going to put a space between it, and it's going to do it again. You'll notice it's a print statement, not a print line statement. So this isn't done on a new line. You can, if you put the line, it adds a new line by default, and it print them all in an individual line, which obviously is not helpful. We want all of them in the same row to print in the same line. However, since this for loop is, you'd use the term nested within this for loop, i.e. this for loop executes within this for loop, the y value is not going to change. The only value that's going to change is the x. So this value, when we loop through this loop a second time, this here isn't going to change. This is. And what's going to happen is this going to go all the way through, all the way up to 6. It's going to fail at 7, and it's at that point that it goes back up to the top of this statement. So this statement fails out, and it's going to go back up to the top of this, and it's going to come back down, loop through this again. However, it's going to have, oh my gosh, I've told you totally wrong. No, so since the y is inverted, y is actually the entire time going to be equal to 5. And when we loop back round, it's going to decrease it by 1. So once it's looped through this loop is going to call again, and this loop doesn't know about the previous loop. It doesn't know that it's run. It's just going to treat it as if it's being run for the first time. Therefore, x is going to be reset to 0. So if we go through again, this time we're actually going to do it correctly. 2, 3, 4, 5, and 6. 6. It's going to get to that point. This loop's going to fail. It's going to go back up to the top. It's going to decrease 1 from y. Go back down again. This is going to be reset to 0. And this time it's going to be set to 3. And that's how that's going to work. I think that's enough for today. I've made various blunders, so I do apologise. And I hope you'll stick with me for the next one.